So now we're going to take some of these points and plug them in a residual graph to find something called residuals. To find our residuals, we need something called a line regression equation. And all we have to do for that is, step one is to pick 2 points on the line, and our points are 10, 4, and 14, 10. Then all you have to do is find the slope, which is y2 minus y1 over x2 minus x1. We're going to take y2, which is 10, put that right there, subtract it by y1, which is 4. We're going to put that over x2, which is 14, minus x1, which is 10, which that equals 3/2. Step 2 is you're going to use that slope 3/2 of those points and one of the other 2 points again, and we're going to plug it into the point slope formula, which is y minus y1 equals m parentheses x minus x1 parentheses. The point we're going to use is 10, 4. Okay, so now that we have plugged in our x1 and y1 and x1, all we're going to do is solve for y, which is actually our step 3. And all you're going to do for this is you're going to distribute the 3/2. You're going to get y minus 4 equals 3/2 x minus 15. You're going to add 4 to both sides, and you get y equals 3/2 x minus 11. Now that we have found our line regression equation, which is y equals 3/2 x minus 11, what we're going to do is we're going to plug in one of our points that we found in our scatter plot. The x point of it is 10, so we're just going to plug it in. So it would be y equals 3/2 times 10 minus 11, which equals 4. Now that we have found our predicted value, which is 4, what we're going to do is find our residual. And how you find the residual is y minus y hat. And y hat is the predicted value, and y is the original y value. So we're going to do 4 minus 4, which equals 0. That's our residual. Finally, we have found all of our residuals. So we have 0, 0, -4, 1, and -5. And the reason why these residuals are really good is because they're positive and negative, which means that the line is going straight through the points instead of above or below. And the closer you are to 0, which we have 2 zeros right here, which means that the line is exactly on the best line fit. Now that we found all of our residuals, we're going to plot it on a residual plot. Now I've done all of them except for one just to show you. So what you're going to do is you're going to take your original x and your predicted y, your residual y, and you're just going to plot them. So it's 8, -5. We're going to go to 8, and we're going to go to -5. And that's how you plot it. When you have a scatter plot, there's something called a correlation coefficient. The coefficients are between 1 and -1. -1 means that it's a decreasing plot, and 1 means that it's an increasing plot. 0 means that it has no correlation, which means you cannot determine if it's increasing or decreasing, and there's no line of best fit. If the scatter plot is close together and forms a close linear plot, then it is close to 1 or -1. And this is what a very good linear close together plot looks like. It would be exactly a linear line, and -1 would be a decreasing linear line. So -5 is an example of something that's, this is wrong too, point.
Hey guys, did someone tell you?
-0.5 would be an example of a weaker linear line. It's decreasing because it's negative. And an example of a closer one would be, let's do 0.9. That would be very close together, but it wouldn't be exactly like a linear plot. This would be an example of a 0, which means that it has no line of best fit. You can't tell if it's increasing or decreasing because the lines are just completely scattered throughout. Any questions?
I'm talking about scatter plots, line of best fit, and linear models today. So for scatter plots, in a scatter plot, the data is separated into 3 different types. We have strong positive or negative, weak positive or negative, or no correlation. We would usually ask ourselves some questions before we start to try to interpret the data, like is there any relationship between the data variables? A scatter plot is raw data, so after we plot the data, we ask questions like what type of correlation is it? Alright, so So we would look at the data given to us and just plot out every point because each one of them is a coordinate. So for our table, one of our last ones is 14,4. So we would just go find 14 on the x and go up to 4 and put a point where it is because it's a coordinate. So for this, we would look at our plotted data and draw a line straight through the plotted points that gets as close to the middle of the points as possible. So for this one, it would be a strong positive. So we try to get close to the middle as we can, so it's even on each side. So this is an example of a linear model because the points are set up in such a way that it makes the line straight, and our line of best fit is like linear. So it could be either way, it could be negative or positive, but it's a straight line, so it's linear.
Hi everyone. Today I'm going to be explaining the difference between quantitative data versus qualitative data. And above you have seen the definitions, and now I'm going to get into more detail on the differences. Now, qualitative data deals with descriptions. The data can be observed, but it cannot be measured, and you have to remember that it cannot be measured. And it is colors, smell, textures, beauty, etc. And now quantitative data, on the other hand, deals with numbers, just like qualitative data deals with descriptions. The data can be measured, unlike qualitative data, and it is length, height, speed, weight, and time. And now I'm going to show you an example on how to find the difference between qualitative data versus quantitative data. Now here is an example of a way to find the difference between quantitative data versus qualitative data. Now as you can see, this is a really, really, really expensive painting, and this is a picture of a tree and grass, and it says the measurement right here. So for an example, if I were to point at the green tree, and you can see all the texture and stuff, what would that be an example of? Quantitative data, which deals with numbers, or qualitative data that deals with data?
Quantitative!
Yeah, you're right. Since this is a measurement, it is an example of quantitative data because it deals with numbers. Now, those are ways to find the difference between quantitative data versus qualitative data. And if you have any questions, just please ask now.